Hey there, pre-calc friends. Today we're going to talk about an old concept from geometry about the area of a triangle. How can you find the area of a triangle? If you remember from your geometry days, if you're given a right triangle, which we usually label the bottom side as the B for base, and the left side that's perpendicular, H for height, we knew that the area for any right triangle was 1/2 base times height, or some people know it as base times height divided by 2. And that was great. That was an awesome formula. But now we're in the part of the chapter where not all the triangles are right triangles. So because they're not a right triangle, we don't have a right angle, we can't use this formula anymore. It doesn't make sense. So how can we find the area of a triangle something like this that's not a right triangle? Well, we could try to maybe make a right angle and a right triangle by doing this, but then we have to try to solve for this altitude, this strange line that we just drew, and that might be kind of tricky. Is there a faster way? You betcha. We have a formula. This formula will help us find the area of any triangle. Would it work for right triangles as well? Sure, of course. It'll work for all of them. But just in case you have one that's not a right triangle, this new formula is amazing. All right, in order to use it, what you need to have is a very, very special case that we call side, angle, side. So you can only use this formula if you're in a side, angle, side triangle, meaning do you have two sides and you have the angle in between those two sides. If you have this, then this formula is perfect. Ready? Here's what it looks like. So the area, and for some reason some books use the letter K, maybe because if they use capital A for area, they're worried that you might get confused over here with angle A. So sometimes some books use K for area instead of A. I am fine either way, but actually what I would like to do is I just want to cross out and just write the word area. The area of any triangle is 1/2 A times B. Well, that actually almost sounds like over here, 1/2 base times height, right? And it is, it's very similar. But because it's not a right triangle, what we have to do is we have to multiply it by a trig. And we use sine here. So the area of any triangle is 1/2 one side times another side times the sine of the angle in between. That's angle C, right? We can go up to this picture to verify it. So look and see what they gave us. If I'm saying 1/2 A, B times the sine of the angle C, and that angle C is in between. Here's another version. What if you don't want to use those two sides in that angle? That's okay. Let's use side B and C. So look down here in the formula. It's 1/2 B times C times the sine of the angle in between, sine of A. So again, look up here at the picture. If we label this side C over here, this would be B times C, 1/2 of that, times the sine of the angle in between. And the angle in between is A. Now, I think it's kind of interesting to notice that whatever letters you use, the angle is going to be the letter that you haven't used in terms of A, B, and C. If you go back to the original one over here on the left-hand side, you have A, B, what's left? C, sine C. Over here, BC, what's left? A, sine A. And over here, AC, sine B. But I kind of like this explanation here. The area is basically 1/2 one side of the triangle times another side times the sine of the angle in between those two sides. And that's it. So really important to know that you have to just have an SAS case in order to use this new area formula. Let's give it a shot. Let me see how easy it is. So I've got a triangle here for number one. Two sides of a triangle have a length of 7 and 4. Great, those are my two sides. The angle in between them is 73 degrees. Find the area of the triangle. I think they give us everything, but just to be on the safe side, why don't we go ahead and draw it? Here's A, B, C, side A, side B, side C. So it looks like they gave us two side lengths. Like we can call this 7 and this can be 4. And then they said the angle in between them right here is 73. Well, by looking at that, that is an SAS case. So we can use this new formula. Let's give it a try. The area of this interesting triangle that's not a right triangle, so I can't do 1/2 base times height, is new formula. 1/2 one side, which is 7, times the other side, which is 4, and we multiply by the sine of the angle in between those two sides. And the angle in between those two sides is angle C, and that was 73 degrees. Great, and now you can actually put that directly into your calculator just as it is. I'll put it in mine right now. When I want to do 1/2 7 times 4 times the sine of 73, I get, oh, if I round it, I get about 13.4. And that's the area of that triangle. If we actually pretended like this was a right triangle and we tried to do 1/2 base times height, it'd be 1/2 7 times 4. 7 times 4 is 28, and half of that is 14. So you can see we're kind of close. We're actually kind of close, as if this was almost a right triangle. It's just not, so we can't use this formula. But you can see over here by getting this answer, we're not that far off. It's just been a little warped because it's not a right triangle. So again, look what we did. First of all, we made sure it was an SAS case. Because it was SAS, we can jump right into the formula. The area is 1/2 the two sides multiplied times the sine of the angle in between. And we're good to go. Good. The area of that triangle is 13.4 square centimeters, basically. Awesome. So that's how that formula works. What could we do different? Well, what if I give you a triangle like this and maybe you don't have everything that you need? How could you find what you need? Remember, we need SAS case. In order to find the area of a triangle, I need two sides and the angle in between. But what if I don't give that to you? What if I give you maybe, what if I give you two angles and I give you, say, example, the side in between those two angles? I really, really need to know the area of this triangle. But I don't have SAS, I have ASA. So I can't do the area formula yet. I need to get SAS. Well, if I want to do SAS, knowing that I've got an angle here and a side here, I could use side A, and that would be SAS. Or on the left side, because I have side B and angle A, I could use side C, and that would be SAS. So either way, our first immediate goal is either solve for side A or solve for side C. Well, we can do that pretty easily using the law of cosines. Let's pretend that we want to solve for side A. So that with side A and side B and angle C, we could do the area formula. All right, so here's how this problem would look. Let's say angle A is 47 degrees, angle C is 25 degrees, and side B is 9. So can we find the area of this triangle? And this is, as you see, an angle side angle case. And we thought it'd be really useful if I could find side A. Because if I can find side A, then I would have SAS, and I can use the area formula. Well, why don't we use the law of sines, because we have an ASA case. So let's see what we have. If we have angle A, I can use A over A here. I'll put this in green so you can see it. Sine of A over A. And then I do have B, but I don't have angle B yet, do I? Well, I bet I could find it, because remember, these two angles added together must subtract from 180 to get the final angle. So I can see that angle B is going to be 180 minus 47 plus 25. And that's basically going to be 108 degrees. All right, now we're good to go. Ready? Let's do a law of sines and see if we can solve for side A. So how about sine of angle B divided by side B equals the sine of angle A divided by side A, which I don't know. Once I get side A, I can do SAS and find the area of the triangle. All right, just like before, with law of sines, we cross multiply, and I get A times sine of 108 equals 9 times the sine of 47. All right, let's divide both sides by whatever is multiplying the A. Here, that's sine of 108. All right, that's going to destroy the sines of 108s, and I get side A equals 9 sine of 47, ready to put this in the calculator, divided by the sine of 108 degrees. All right, once I put that inside, let's see, I'm going to type that to my calculator here. 9 times the sine of 47 divided by the sine of 108. And I get that A is about 6.92, or about 6.9. Okay, that looks pretty darn good. All right, now, since we have let's see, we have a side, and we have a side, and we have the angle in between. We're ready. We're ready. Let's do it. Are you ready? Here we go. Area equals 1/2 one side times the other side, which was a given 9, times the sine of the angle in between. And the angle in between A and B is angle C, and that's 25 degrees. All right, let's find this one. Here comes my calculator. I've got the sine of 25. I'm going to multiply that by 9 and by 6.9 and by 1/2. And I get the area of this triangle is about 13.1. So I couldn't achieve that until I had SAS case. So if you're not given SAS case, figure out what case you're given. And you can use law of sines to find whatever you need to get to the end. And there you go. Overall, again, here is the area formula for any triangle in the world. Does this work for right triangles? Absolutely. You can always plug it in. But here it is, 1/2 side times the sine of the angle in between. That's pretty powerful that we can do that for any triangle. Hope you enjoyed. There's your area of a triangle, and we'll see you next time.